Hey CW Apes, Mr. Kennedy here with part 2 of your chapter 21 notes on solid and hazardous waste. In our first video, we spent a lot of time talking about where your garbage comes from and, things like landfills, one option for disposal. In this installment, we're going to focus on some different alternatives to landfills and eventually work through the legislation that regulates what ends up in the trash and who's responsible for cleaning it all up. So we begin with incineration. Incineration, well, simply put, is burning your garbage, right? While that's not really like smiled upon in a state like ours, there are places where, well, this can be done as long as it's done carefully and conscientiously and cleanly, okay? And you can get some positives from incinerating garbage. Not just air pollution, but electricity production. We can even use it as like a heat source to like heat buildings, with steam, along with making that electricity. So there are some positives to it. And probably the biggest positive is that, well, you're burning your garbage instead of burying it in the ground. Okay. Yes, there are some negatives, and we do have to be conscientious and careful about that, which is why I said, as long as you're conscientious and careful and you do this cleanly and correctly, like there are some positives, but that's a big if at the front end. Okay. So in an incinerator, basically what you're going to do is you're going to take your garbage, you're going to burn it, and then use the heat energy released from that to boil water, produce steam, and maybe make electricity or heat a building. That's the idea. Internationally, there's well over 1,000 waste to energy plants that do reduce the garbage stream for a variety of different countries. Right? Now, when we think about these incinerator types and the waste to energy plants, there's a couple of different types that I want you to be familiar with. There is a refuse-derived fuel plant, and in this case, the refuse will be sorted to remove recyclables and unburnable materials, and then the higher energy content, basically raw trash that's remaining, that's what's burned. And the flip side, you have what's called a mass burn incinerator. If it's a mass burn, then everything smaller than major furniture and appliances is loaded into the furnace and just like burned. The problem with mass burn is we do have serious issues with air pollution from the exhaust. Okay. So you got to employ some sort of technology to clean the exhaust from the incinerator. Otherwise, you're going to throw all manner of chemicals and chemistry up into the atmosphere, which can lead to everything from, climate change to acid rain and anything in between. Now, incinerators do have the potential to reduce our disposal volume by about 80 to 90% because, when you burn something and you take it from its raw form into ashes, like the ashes take up a lot less space. The bad thing about the ashes is that these ashes, after you go through this incineration process, often contain toxic materials and require disposal in special landfills that only handle hazardous materials. Okay, so not really a great viable option. When you think about like weighing the cost of the energy production and then having to deal with toxic waste when it's all said and done. What's probably going to be better than looking at like incinerators to reduce the garbage that we have is just don't make all that trash to begin with, right? This is what a mass burn incinerator might look like. It's important that you understand how energy is produced for your tests, for your AP tests, and it's a repeating theme, always a repeating theme. When you think about making electricity, you got to have a turbine that rotates, a generator that produces electricity. The only difference between, say, fossil fuels and renewable energy like wind is what's rotating the turbine. In this case, the turbine's being rotated by steam that is produced from boiling water, and that water is boiled by the heat of you burning trash. If we're doing wind power, well, then it's just wind that's blowing that turbine around like a windmill, right? And we're making our electricity from there. All right, so a few statistics on cost and safety. The initial construction costs of an incinerator are usually between $100 and $300 million for a typical municipal facility. Tipping fees, or basically the cost to dump a ton, are often much higher than tipping fees at landfills. So if you had an incinerator in your city, neighborhood, whatever you want to say, to use as a way to get rid of your garbage, you could expect your garbage bill to go way up, right? Because it's expensive to build the plant, and then you're going to have to pay more to actually dump the stuff than you would if it was just a hole in the ground. Hence the preference to landfills versus incinerators, not to mention the air pollution. Okay. The EPA has found alarmingly high levels of dioxin, furans, lead, and cadmium in the ash that comes from incinerators, which means it's toxic stuff. So we gotta deal with that too. This is another graphic to help you understand the pros and cons of a waste to energy plant. If you just want to make a list, pros, cons, here you go. So the pro is the trash is burned, the heat is used to generate electricity. The cons, we get carbon monoxide, carbon dioxide, particulates, heavy metals, toxic chemicals are produced. It's expensive. It's expensive to control the pollution. It's expensive to generate power this way. It's expensive for you to just dump your trash at this plant. And yeah, there are about 1,000 plants worldwide and 110 even in the United States. Okay, let's look at ocean dumping. So ocean dumping, its name is self-explanatory. We talked about it in our past video. A garbage truck a minute round the clock backs up to the ocean and basically dumps its contents thusly. So we have in the ocean, as a result of all this dumping, a couple of, well, not a couple, multiple garbage patches that form in the Great Pacific gyres that form as the currents mix the waters of the Pacific Ocean. The Great Pacific Garbage Patch is the most famous of these gyres and collections of plastic waste. The Great Pacific Garbage Patch sits just to the north of the Hawaiian Islands. And, well, there's so much plastic there, so much garbage there floating on the surface that basically they said even if we stopped dumping the trash now and went after cleaning up all this plastic, we'd probably never be able to get all of it out of the ocean. The Great Pacific Garbage Patch by itself is the size of 2 of the states of Texas or 3 of the countries of France, depending on how you want to lay it out there. And it's about 3 feet thick, right? And just soupy goo. The dangerous part of this Great Pacific Garbage Patch is that the plastic does not break down into something that, well, is usable by the environment. It forms actually tiny little drops of plastic called microplastic that can work their way through the entire food chain, even all the way up to people. So ocean dumping was banned in 1988. Yeah, 1988, not 1888, not 1788. So that means all the way up to 1988. Like, even in countries like the United States, they were still allowing ocean dumping, right? That's just mind-blowing in my own head. But Ocean Dumping Ban Act of 1988 was passed to prohibit all municipal sewage, sludge, and industrial waste dumping into the ocean. So yeah, this is a picture from 1964 where the U.S. Army was even guilty of dumping in the ocean. They took mustard gas that wasn't, going to be used anymore, and basically just thought, well, the easiest thing for us to do is throw it into the bottom of the ocean. All right. So at the end of the day, this is a serious problem. And trying to find a place to put our waste, this is something that society is going to have to deal with, forever. So what we really need to do is figure out a way to not produce the waste in such large quantities to begin with. And that's where things like integrated waste management and the concept of reduce, reuse, recycle really to start becoming important and hold their own. Integrated waste management is all about finding the best use for discarded products through reduce, reuse, recycling, composting, and things of that nature. So if you follow this flow chart, At home, how many municipal waste containers do you have? Like 3? You got one for green waste, one for recyclables of all kinds, and then one for what we would just call trash, right? But which one fills up first, and where does it go, okay, once it's filled up? That's the problem. Okay, that's the question that we got to deal with. And as you can see from this, unfortunately, a lot of stuff still ends up in hazardous waste disposal sites, incinerators, and landfills. Okay. When we think reduce, reuse, recycle, what I want you to think about is, well, reduction is all about reducing how much you throw away. As consumers, if you don't buy it, they won't build it. And one of the big things in the reduction area that we got to look at is over packaging of products. I have for years asked, why do we have to have a cardboard box wrapping around a plastic bag of cold cereal on the shelf in our grocery stores? That's not the only offender. It's just the one that always comes to my mind. I get you need the plastic bag maybe to keep it fresh, but do you really need the cardboard box too? It's just a case in point. There's lots of different things that I'll share with you throughout the year about over packaging. I've seen fruit like bananas on a foam tray wrapped in plastic because what? The banana doesn't have its own wrapper already? That's over packaging. Like, we need to reduce what we throw away by not buying things that are over packaged to begin with. And if we don't buy what's over packaged, then maybe they won't over package those products or make those. Recycling is the process of taking discarded materials and converting them into something like completely different than what they were before. So that's the concept. In recycling, it's not taking your water bottle and using it for water again. It's taking your water bottle, grinding it up into little chunks of plastic, and then maybe using that water bottle to make shoes, right? Believe it or not, they can even make clothing out of plastic nowadays, right? And it actually feels like cotton. The technology is there. Currently, about 2/3 of all aluminum cans are recycled. Old tires can be turned into road surface if there is a desire to do so. Newspapers, newspapers are getting hard to find, but in places where newspapers are still common, it can be used for insulation. Recycling copper is so lucrative, well, that even we have a hard time protecting copper wires, copper pipes, and all that kind of stuff like that from thieves. At the end of the day, what I really think drives recycling more than anything else is what's mentioned in that last point. If I have to pay 3 cents or 5 cents for a California redemption value on a can or a 2-liter bottle, and I could take to the recycling center and get my 3 or 5 cents back, well, then maybe it's worth it. But unfortunately, what's happening is we take stuff to recycling center, we don't get much money back. There's this mindset in recycling of what's in it for me. And oftentimes what's in it for me means money. I need to have money, for the what's in it for me. So if I'm not getting paid the big bucks for bringing, 10 pounds of aluminum cans to the recycling center, then it's not worth my time. One case in point where it is worth a lot of your time is in car batteries. We actually charge people anywhere from $12 to $15 for what's called a core charge on a car battery. As a result of doing that, more than 90% of car batteries today are now recycled because, you're getting like $12 back for bringing your battery, to the business that you bought your new battery from. So maybe if you got paid better for aluminum cans, I don't know, instead of 2/3, it'd be 100%. We shall see. Benefits of recycling: it does save money, it does save raw materials, it does reduce what's going into a landfill, so it saves space there. Costs about $35 a ton as opposed to $80 a ton to landfill. So $35 a ton to recycle it, $80 a ton to bury it. It encourages individual responsibility. It reduces pressure on disposal systems. Like, Japan recycles about half of all of their waste. It lowers the demand for raw materials, so we don't need to go dig it out of the ground and all of that. We've already got it. and it reduces energy consumption and air pollution. Present policies do tend to favor the use of raw materials because energy, raw materials, and water are often sold below the real cost to create jobs and stimulate the economy. So we might, have the ability to recycle a lot of stuff, but it's not all getting recycled because you could go dig raw materials out of the ground and it's cheaper than buying the recycled materials. Okay, this is recycle rates that you see for different things in the United States. And look at the auto batteries. Remember what I told you? You got to pay about $12 core charge for that auto battery. That's why most of them are getting recycled. Look down there at the bottom. Very few people are recycling glass. You don't get paid for it well at the recycling center, so people aren't doing it. Okay. Again, recycling means we're going to literally melt the material down, reprocess it into something new. And there's two types of recycling that I want you to be familiar with: closed looped and open looped recycling. Closed loop recycling is basically producing the same thing after processing. So you take a plastic bottle, you break it all the way down, and you got a new plastic bottle out of it, right? Open loop is where you make something different. So that plastic bottle could maybe become a pair of shoes or something like that, right? So going back to the incentives, in California, all carbonated beverages sold in aluminum cans, glass bottles, and plastic bottles require a deposit. The deposit amount right now is about 2.5 cents for containers under 24 ounces and 5 cents for containers above 24 ounces. You can redeem this at any redemption center, but there's always one of those. At the end of the day, you don't get that full value. If I paid 2.5 cents for an aluminum can's CRV value, when I go to the recycling center, I don't get 2.5 cents per can. They'll actually pay you by the pound, and it is much less than that. So that's where we have the problem with the recycling thing and how much people are making and whether it's worth their time. Okay. I don't have all the answers. Maybe we jack up the CRV value, people get paid more, and it becomes more attractive, like I said before. I don't know. Something for us to consider. When you recycle paper, well, that's huge for us. One Sunday paper requires 500,000 trees to produce for the average city. 40% of that paper is recycled today, which is awesome. Recycling metals other than aluminum, copper, lead iron, steel, zinc, etc. These are still profitable to recycle. There are some metals that basically no one wants at the recycling center, and unfortunately they just end up in the landfill. There's a big old pile of copper wire there for you. That's probably the most valuable of all the metals to recycle. When it comes to plastic, only about 2.5% of plastic is actually recycled. Plastic is much more difficult to recycle than paper, aluminum, or glass. It's made up of this material called polyethylene, right? And basically, the more polyethylene you have in the bottle, well, the easier it is to actually recycle that plastic. If you look at your water bottles, your milk cartons, and stuff like that, there's actually recycling codes associated with them that look like this. Depending upon how much polyethylene is in them, you'll get a little bit different number associated with them. So you could have a polyethylene number of 1, 2, or a 3, and then as the plastics start to change, you could end up with 4s all the way up to 7s. And basically, as you change those, the plastic changes, and how we handle that plastic in the recycling process also has to change. Even its value changes. When you think about plastic bottles, the ones with the 1 on it are actually the most valuable at the recycling center. And then it just goes downhill from there. Okay. All right. So that brings us to commercial scale recycling and composting. Now, we could do what we do around the house, but if we really want to make a dent in the waste stream, we need to get to a commercial scale of recycling and composting. There are plenty of great examples of commercial scale recycling and composting, locally. Probably one of the best that I've ever seen is at a place called Gallo Winery. Gallo Winery takes all of the grapes from their crush, they fold it in with yard waste that they allow the surrounding community to deposit, and they make compost, they make flower bed bark, they do all kinds of things like that to get this material out of the waste stream. Yard waste alone makes up 12% of the waste stream. So just by recycling and composting what they're doing at Gallo Winery, like they're having a major impact on what could have or maybe would have ended up in the landfill. There's a Swiss company that uses yard waste to actually make methane, and then it becomes something great for energy production. Construction waste can also be recycled. Gasifiers can convert biomass from food-soaked paper even to natural gas. So there's all kinds of potential in commercial scale recycling. E-waste. Well, that's another problem. Do we ship it overseas? Like, what do we do with our used up TVs? Things like that. At the end of the day, demanufacturing is the only way to handle our e-waste. It's the disassembly and recycling of obsolete appliances. It's time consuming, it's expensive. That's why a lot of this stuff gets shipped overseas. In Europe, manufacturers now have cradle to grave responsibilities for their products. In the United States, we don't have that just yet for every product, so still a lot of it is shipped overseas. 70% of heavy metal contamination actually comes from e-waste, and batteries make up another 10 to 20%. You know, the old alkali batteries that are running your remotes? That's them, okay? Reuse. So at this point, we've gone through the reduce and the recycle. So let's talk about reuse. Reuse is actually more efficient than recycling. This is basically the whole idea of taking that water bottle that you're drinking out of and, I don't know, making a planter out of it, a pencil cup out of it or something. You're not going to chip it up, melt it down or anything like that, but you're going to give it new life in some other like avenue, some other functionality, right? Auto parts, brass fittings, woodwork, bricks, they're all routinely reused and can sometimes bring a higher price in construction. There's actually a market for things like used brick as opposed to new brick. Glass and plastic bottles can be washed and refilled. In developing countries, poor people can make a living by scavenging, sorting, and reprocessing scraps from dumps. So there is a lot of value in these things. Reusing things again will help you shrink the waste stream, basically produce less waste. Excess packaging from consumer products, all this stuff, we got to get it out of the waste stream. Paper, plastic, glass, metal packaging actually make up 50% of domestic trash. We need to decrease this unnecessary packaging, right, and increase the use of photodegradable and biodegradable products. By 2020, new laws in the European Union actually mandate that 50% of municipal solid waste and 70% of construction waste be reused or recycled. That's pretty awesome. Okay. All right. So I'm going to skip forward now to the whole idea of the laws and legalities that are surrounding this stuff. Okay. And look at some hazardous and toxic wastes to wrap up our time together. So when we're talking about hazardous and toxic waste, we got to enter the land of the EPA. The EPA estimates U.S. industries generate 265 million metric tons of officially classified hazardous waste annually. At least 40 million metric tons of toxic and hazardous waste are actually released into the environment. That's not okay. This is kind of stuff that we got to stop. So there are laws, there are rules, there are regulations around these things to help prevent this stuff, right? Let's take a look at some of those laws. Legally, hazardous waste is any discarded liquid or solid that contains a substance that is known to be fatal to humans or laboratory animals in low doses. It could be toxic, it could be carcinogenic, it could be mutagenic, teratogenic to humans or other life forms. It could be ignitable with a flash point of less than 60 Celsius. It could be corrosive. It could be explosive or highly reactive. That's what it means to be hazardous, okay? The first law that I want you to be familiar with is the Resource Conservation Recovery Act, RCRA, passed in 1976. So this is federal legislation, a comprehensive program that basically requires rigorous testing and management of toxic and hazardous materials. This is a cradle to grave accounting for these toxic materials. Okay, it's federal law. We don't have it covering everything, but it's a step in the right direction. The cradle is the point of generation. The grave is the ultimate disposal. Okay. We also have what I like to call CERCLA, which is the Comprehensive Environmental Response Compensation and Liability Act that was passed in 1980. This is a modification of the Superfund Amendments and Reauthorization Act, or SARA, which was, which was passed to amend the CERCLA in 1984. And both of these basically are aimed at rapid containment, cleanup, and remediation of abandoned toxic waste sites. They even establish a community's right to know as to what's been going on this land, what was there before. There are some videos that we're going to watch in class that deal with things like the Love Canal in New York, where, companies just basically buried toxic materials underground and didn't tell anybody. And it wasn't until like everybody on the street ended up with, skin rashes and weird cancers and stuff that, it finally came out what happened. So it's a really good thing that we have these two laws in place and this right to know. Toxic release inventory requires 20,000 manufacturing facilities to report annually on releases of more than 300 toxic materials to protect the community. Okay, so these are just a couple of laws that I wanted to share with you. This is just a reiteration of the CERCLA law, but let's skip over that and talk about a Superfund site and end this whole thing. So a Superfund site, the EPA basically monitors any kind of spill or toxic or hazardous materials release that occurs anywhere in the United States. EPA estimates that there's 36,000 seriously contaminated sites in the United States. In the General Accounting Office, it says that there could be as many as 400,000 sites. A Superfund site is created anytime a business or industry of any kind, makes a mess. We'll put it like that. There's toxic materials that are spilled. There's some sort of activity that pollutes the water, the ground, the air, and it's got to be cleaned up. By 2007, 1,680 sites have been placed on the national priority list for cleanup with Superfund financing. Superfund is a revolving pool of money that's basically designed to provide immediate response to emergency situations posing imminent hazards and to clean up abandoned and inactive sites. In 1995, Congress, they basically let the polluters pay tax expire. So unfortunately, today, taxpayers absorb the cost of cleanup. That's not good, okay? When you think about Superfund sites, the total costs for hazardous waste cleanup in the U.S. are estimated between $370 billion and $1.7 trillion of taxpayer money. And most of the sites that need to be cleaned up are old industrial facilities, chemical manufacturing plants, and places like the Great Lakes. But believe me when I tell you, there are dozens even in your home state, okay? Studies of Superfund sites reveal that minorities tend to be overrepresented in these neighborhoods, which is a form of toxic colonialism, something that you learned about in a past video. This kind of gives you a map of hazardous waste sites in and around the United States. You can see lots of those are concentrated over towards the East Coast. All right, brownfields. Brownfield liability and opportunities. Brownfields, these are contaminated properties that have been abandoned or are not being used up to their potential because of pollution concerns. So the idea of a Superfund, is basically to avoid getting stuck with brownfields, places that a business once existed but ruined and now it can't be used. Up to 1/3 of all commercial industrial sites in the urban core of many big cities actually still fall into this category. That's why you might drive around big cities, especially in the industrial areas, and just find empty lots with nobody building on them. In many cases, property owners will complain of unreasonably high, purity levels, and basically say, "Well, I can't ever get it this clean, so I'm just not gonna." Right? That's the problem. Then the field or the area lies unused. So when you think about hazardous waste management, okay, the Superfund is really our best bet at cleaning them up, and then using the RCRA and the CERCLA, federal legislation to protect us from those types of spills. It's really our best bet in managing hazardous waste. Outside of that, we've really just got to focus on not producing the waste to begin with, avoid creating waste in the first place, reduce, reuse, recycle, use less toxic alternatives, convert to a less hazardous substance, physical treatment, incineration, chemical processing, even bioremediation would be great strategies to employ rather than just bury this stuff in the ground. Okay. Storing it permanently is an option, but again, that's expensive. Like, where are you going to put it? Nobody wants this stuff in their backyard. If it's retrievable storage, then it can be in containers in places like salt mines or caverns, or maybe you could put it in a secure landfill, which is kind of a modern complex landfill with like multiple liners to protect you from leachate and gases escaping and all that kind of stuff. But again, it goes back to like, why make this stuff to begin with? All right, ladies and gents, that brings us to the end of our story on solid and hazardous waste. I hope you've learned a lot. I hope you remember to always reduce, reuse, recycle, and to keep that waste stream as small as possible. I'm Mr. Kennedy, and I will see you next time.